Hi, welcome to the Section 3.2 video lecture. Today we're going to talk about the derivative as a function. So in the last section we talked about how to use the difference quotient and its limit to find derivatives at an individual point. But today we're going to look at, well, what do we have to do with this to find an equation for the derivative so that we'd be able to find the derivative of a function at every point. So go ahead and take out your note sheets, which once again can be found by going either to this week in your Blackboard course or under handouts in my math lab, depending on your course format. And we'll go ahead and start working through this. So the derivative of a function f of x with respect to the variable x is the function f prime, whose value x is given by f prime of x equals the limit of the difference quotient. The domain of f prime is the set of points in the domain of f for which the limit exists, which means that the domain may be the same as or smaller than the domain of f. If f prime exists at a particular x, we say that f is differentiable or has a derivative at x. If f prime exists at every point in the domain of f, then we call f differentiable. The process of calculating a derivative is called derivation. To emphasize the idea that the differentiation is an operation on the function y equals f of x, we use the notation d over dx f of x. So we are taking the derivative of function. So we're using that notation. So for example, if I want to find the derivative of k here, what I want to start out by doing is finding its derivative, and then I can find these individual values. So what I would do here is I would take d dz of kz equals d dz of 1 minus z over 2z. So that's how we could use this new notation to write that we're taking the derivative of k. So the derivative of k is k prime of z, right? That's the notation up at the top. And then to find that, we're going to do this limit. So this will be the limit as h approaches 0, which I just noticed up here in the definition is a typo. That should be the limit as h approaches 0 of k of z plus h minus k of z all over h. Okay? And so to find that derivative, what we're going to do is we're going to try and find this limit, not just at one point, but for z and h in general. So this will be k prime of z. So now we're going to plug z plus h and z into this function. So it'll be 1 minus z plus h over 2 times z plus h minus 1 minus z over 2z all over h. And we're taking the limit of that. Okay. So now what we want to do is the same thing we did when we were doing this for an individual point. We want to, we've got a complex fraction, so we want to get rid of that. And the way we get rid of that is by multiplying by the least common denominator. In this case, that's going to be 2 times z plus h times z. So these two denominators, right here and right here, share the number 2, but the rest of them are different. Z plus h is a different value than z. Okay, so that's why we include both of those. Okay, so k prime of z will equal the limit as h approaches 0 of 1 minus z plus h, which I can go ahead and simplify a little bit to be 1 minus z minus h over 2 z plus h times 2 times z plus h times z minus 1 minus z over 2z times 2 times z plus h times z all over h times 2 times z plus h times z. Okay, so now what we want to do is we want to do some simplification. So in the first one, the first fraction on top here, the 2's cancel and the z's plus h cancel. So that just left me with z. So this will be 1 minus z minus h times z minus, over here the 2 cancels and the z cancels. So this will be 1 minus z times z plus h all over 2zh times z plus h. Okay. Now I want to distribute, right? Get rid of the parentheses on top. So k prime of z will be the limit as h approaches 0 of z minus z squared minus zh minus, and notice here we're going to get the opposite of everything because we've got this minus out in front. So 1 times z is z, so that'll be negative z. 1 times h is h, so that'll be negative h. Negative z times z is negative z squared, but it's the opposite of that, so it'll be plus z squared. And negative z times h is negative zh, but it's the opposite of that, so it'll be plus zh all over 2zh times z plus h. Okay, so now we combine like terms. So k prime of z equals the limit as h approaches 0. Well, z minus z cancels. Negative z squared and z squared cancel. Negative zh and zh cancel. And so we're just left with the opposite of h on top. So this would be the opposite of h over 2zh times z plus h. Okay, and so now we'll come back up here to the top. So k prime of z equals the limit as h approaches 0. And one thing we can do is cancel the h. So this will be negative 1 over 2z times z plus h. And now we can plug in 0 for h to find that limit. So k prime of z is negative 1 over 2z times z plus 0, which would be k prime of z is the opposite of 1 over 2z squared. And so there's our function, k prime of z. There's the derivative. So now what we want to do is we can now use that to find multiple values. So you just do, so to do k prime of negative 1, we just plug in negative 1. So that would be negative 1/2. And then we can do k prime of 1, which would also be negative 1/2. And we could do k prime of the square root of 2. Which would be negative 1/4. Okay, and so that's all there is to that. So we're doing the same things we did in the last section. We just have more variables running around because we're not plugging in a value for x. Or in this case, z. So let's try a couple more of those together. Or at least let's try one more together and then I'll have you guys try one. So for the next one, if I want to find r prime of s, that just means I'm going to take the limit as h approaches 0 of r of s plus h minus r of s over h. So in this case, that would be the square root of 2 times s plus h plus 1 minus the square root of 2s plus 1 all over h. So now we can simplify a little. So this is the square root of 2s plus 2h plus 1 minus the square root of 2s plus 1 over h. And so now, notice we're dealing with a square root. We cannot plug 0 into the denominator yet because that would make this undefined. So what we need to do is we need to multiply by the conjugate. And the conjugate in this case is the top with a plus in the middle, right? So the square root of 2s plus 2h plus 1 plus the square root of 2s minus 1 plus 1. I don't know where that became a minus 1. Over the square root of 2s plus 2h plus 1 plus the square root of 2s plus 1. And so r prime of s is equal to the limit as h approaches 0. On top, remember, when you multiply these, they cancel, but the second term is negative, so this would be 2s plus 2h plus 1 minus 2s plus 1 all over h times the square root of 2s plus 2h plus 1 plus the square root of 2s plus 1. Okay, and now we can combine like terms. So we've got 2s and we're at negative 2s, so those will cancel. We've got a 1 and a negative 1, so those will cancel. So this will be r prime of s equals 2h, the limit, as h approaches 0, of 2h over h times the square root of 2s plus 2h plus 1 plus the square root of 2s plus 1. And now we can cancel an h, and now I can plug in 0. So r prime of s equals 2 over the square root of 2s plus 2 times 0 plus 1 plus the square root of 2s plus 1, which equals 2 over the square root of 2s plus 1 plus the square root of 2s plus 1, which equals 2 over 2 times the square root of 2s plus 1, right? Because I've got two of the same thing added together. So that's the same thing as twice that. And now I can cancel the 2. So this would be 1 over the square root of 2s plus 1. And so there's our derivative. And just like on the previous problem then, to find r prime of these numbers, you're just going to plug them into this new equation. So r prime of 0 would be 1 over the square root of 2 times 0 plus 1. So that would be 1 over the square root of 1, which is 1. R prime of 1 would be 1 over the square root of 2 times 1 plus 1. So that's 1 over the square root of 3, which if we rationalize the denominator is the square root of 3 over 3. And the last one, r prime of 1/2, is 1 over the square root of 2 times 1/2 plus 1. So that's 1 over the square root of 2, which we can do the same thing as the one above it and get the square root of 2 over 2. Okay, so that's the idea. So what I'd like y'all to do now is pause the video and try doing the same thing for the one below it. Okay, so let's go and try this one together. So f prime of x is going to be f of x plus h minus f of x over h, and we're taking the limit of that as h approaches 0. Okay, so in this case, f prime of x would be the limit as h approaches 0 of x plus h minus 1 squared plus 1 minus x minus 1 squared plus 1 all over h. Okay, so what we want to do now is we want to multiply the stuff out on top and simplify, right? That's what we do when we're doing this with polynomials. So x plus h minus 1 squared is going to be x squared plus xh minus x plus xh plus x squared, h squared, sorry. Minus h, and then minus x minus h plus 1. Plus another one. And then over here on the right-hand side, this is going to be minus x squared minus 2x plus 1 plus 1. All over h. Okay? And so now we can try and combine like terms. So let's see what we got. We've got an x squared and a negative x squared, so those cancel. I've got two xh's, so 2xh. I've got a negative x and a negative x and a positive 2x, so those cancel, right? Because this negative distributes. I already did the xh. I've got an h squared So plus h squared. I've got negative 2 h's, and I've got 1, 2, positive 2, and a negative 2 in there, so those all cancel. Right, because all the ones inside the parentheses are the opposite of that number because I've got this negative out in front. All over h. And now we can cancel. So this will be f prime of x equals the limit as h approaches 0 of 2x plus h minus 2. Plug in 0 for h, and you get f prime of x equals 2x minus 2. And so now you can plug those values in. So f prime of negative 1 is 2 times negative 1 minus 2, which is negative 4. Capital F prime of 0 is 2 times 0 minus 2, which is negative 2. And f prime of 2 is 2 times 2 minus 2, which is positive 2. Okay, so this is just like what we did in the last section. It's just a little more complicated because we're not dealing with as many numbers. We're not dealing at a specific point. We're looking at the whole function. So we end up with a lot of variables moving around. Okay, so on the next 2 pages, I just want to look at some different notation that is not a new type of problem. So we're probably not going to do the problems here, but there is a bunch of different notation that runs around a calculus, and I want to make sure you understand what it means. So basically there were 2 people who invented calculus simultaneously but separately. Isaac Newton, English mathematician and physicist, and a German mathematician and physicist named Gottfried Leibniz. And because they were creating a new math on their own separately, they came up with different notations for this. And that's kind of true about math in general. Calculus, compared to other math that you've done so far in your life, is relatively young. Calculus is only a few hundred years old. So it has not necessarily a time to standardize its notation as much as things like algebra has, which is centuries, several millennia old even, has had time to standardize a lot of its notation. So we ended up with a lot of different ways to say the same thing. And so I've listed a bunch of different ways to write the derivative here, and these are all the same. And these first 3 are the most common. So for example, in this case, right here, when it asks you to find dv dt, all that really is asking you to do is find v prime or v prime of t. Okay, which is the same thing we had before. So that's all these are looking for. So I don't want to spend a whole lot of time in the video looking at that because you guys will get a lot of practice with this in the assignment. Similarly, here is another notation for finding a specific function value. So for example, if I say dw dz and then I draw this line and f4, what that means is find w prime of 4. So find the derivative and then plug 4 into it. Okay, so that's all that we're looking over. So these are just different notations for things we've already talked about how to find. There is one more thing, however, that we actually need to practice using in this section before we're done with this video, and that is an alternative form for finding the derivative. So in the current form with the difference quotient that we've been looking at, the idea is we're finding the average rate of change, and where h stands for the distance between the points. And we bring the points closer and closer together until they are the same. So we let h go to 0, because when 2 points are the same, the difference between them is 0. The distance between them is 0. Another way to think about this is to think about the points x and z and allow them to approach each other until they're the same point. So allow z to approach x. So that's the idea here, is we're using 2 different inputs, 2 different domain variables, and then we're going to make them approach each other until they're the same, and we'll get the same result. And this can be useful for finding different types of derivatives. So like, for example, I could use this to find the derivative right here. So if I wanted to find g prime of x, I just do g of z minus g of x over z minus x, and I find the let's erase a little since this is the first step. I find the limit as z approaches x. Okay, so that's, we're finding g prime of x. Okay, so what would that look like? Well, in this case, that would just be 1 plus the square root of z minus 1. Shoot, I forgot to write the limit again. So let me just write it down here. let's write here instead. The limit as z approaches x, that would be 1 plus the square root of z minus 1 plus the square root of x over z minus x. And then we can get rid of the parentheses. So this is the limit as z approaches x of 1 plus the square root of z minus 1 minus the square root of x over z minus x. And then the limit as z approaches x, the 1 and negative 1 cancel. So it's the square root of z minus the square root of x over z minus x. And we can't just plug x in for z here because x minus x would be 0 and that would be undefined. So we can't do that. But we have two radicals. We know what to do when we have two radicals and we can't find the limit yet. We multiply by the conjugate. So this would be z plus the square root of x over z, the square root of z plus the square root of x. Multiply those out. Square root of z times the square root of z is z. Square root of x times the square root of x is x. So we get z minus x times the square root of z minus the square root of x on the bottom. Now we can cancel out z minus x. So this is the limit as z approaches x of 1 over the square root of z minus the square root of x. And now we can just replace z with x. So this will be 1 over the square root of x, sorry, not minus, plus the square root of x. So the square root of x plus the square root of x, which is 1 over 2 times the square root of x. And that's all there is to that. So why don't you guys go ahead and pause the video for a moment and try finding this second derivative using this alternative method. Okay, now that you've had a chance to try it on your own, let's try it together. So f prime of x equals the limit as z approaches x of f of z minus f of x over z minus x. So f prime of x is going to be the limit as z approaches x of z squared minus 3z plus 4 minus x squared minus 3x plus 4 over z minus x. So that's, we can get rid of the parentheses. So this is z squared minus 3z plus 4 minus x squared plus 3x minus 4 over z minus x. We can cancel out the 4 and the negative 4. So this is f prime of x equals the limit as z approaches x of z squared. I'm going to reorder this now because what you might want to do at this point, oh, never mind. Don't reorder yet. 3z minus x squared plus 3x. And now we can factor the top by grouping. So out of the first ones, I can factor out a z. So that's z times z minus 3. And then the second ones I can take out a negative x. Nope, I take it back. I do want to reorder those. Sorry, I did a mistake there. So I'm going to reorder these terms in this step. So I'm going to put the z squared and the negative x squared together, and the negative 3z and the positive 3x together. And now I'm going to factor by grouping. So from the first two, that factors as z minus x times z plus x. And over here I can factor out a negative 3. So I'm left with z minus x over z minus x. And now I can cancel the z minus x's because there's one in each term. So f prime of x equals the limit as z approaches x of z plus x minus 3. And now replace z with x. So this will be x plus x minus 3, which is 2x minus 3. Okay, and that works out. So that's the idea of the alternative method. This one on top is a good example where the alternative method works a lot easier than the regular method. The one on the bottom is not necessarily as straightforward. So that's it for this section. As always, if you have any questions or concerns about this section or anything else, feel free to contact me and we can talk about it. Don't forget to do your homework and the quiz.